Hi folks, welcome to 7.4 dot products. So today we're going to talk about what a dot product is, and we're going to start with the definition. So what we're doing is we have a situation where we have two vectors. So we have vector A, that's in component form A1, A2, and separately we have vector B, which is B1, B2. Now, both vectors can be written in the ij form, or a1i plus a2j, and then vector b can be b1, bi, and b2j. And so the dot product of a and b is given by the following formula. So a dot b, and that's not a multiplication symbol, it's a dot, okay? So a dot b means basically that you take the horizontal components, so a1, b1, okay? So these are the horizontal components, and you multiply them together. And then you take the vertical components and you multiply them together, and then you add at the end. Okay, so knowing that, let's try practicing the basic process of how you find a dot product. So, example 1 here, we have A equals -5, 3, and B equals 3, -7. And so the first question is asking us to find A dot B. So we're going to plug that into our formula where we have A1, B1 plus A2, B2. And we're going to plug in our numbers. So we've got -5 times 3 plus 3 times -7. And just to clarify, we have A1, A2. All right, so this is A1, this is A2. And then we have B1 and B2, or B1 and B2. Now, once we've plugged in all our numbers, we just have to multiply them. We'll get -15 minus 21, and we will end up with a dot product of -36. All right, so let's take a look at question B. So question B says, instead of A dot B, I want you to find B dot A. And so what we're going to do is we're going to plug this into the formula. So if the numbers are switched around, then we have to switch around accordingly. So this will be B1, A1 plus B2, A2. So let's take a look back at the numbers we have. B1 is 3 times A1 is -5 plus B2 is -7 times A2 is 3. And I'll get -15 minus 21, which gives me -36. All right? So if you do A dot B and then B dot A, this and this should give you the same number. Okay, let's take a look at example number 2. So we've got two other vectors, A equals 4i plus 6j, and B equals 2i plus 6j. And this time I want you to find A dot B, and then I want you to find B dot B. So A dot B is going to be A1, B1 plus A2, B2. And the i's are going to be our 1's, and our j's are going to be our 2's. So we'll have 4 times 2 plus 6 times 6. And that will give us 8 plus 36, or a total of 44 for our dot product. Now, if I were to ask you to find B dot A, you should also get 44, because A dot B equals B dot A. Okay? So it's nice to know that you can switch around the order when you need to or when you want to. And let's take a look at part B here. So part B says B dot B. So the way that works is you have B1, B1 plus B2, B2. And when we use our numbers, we'll get 2 times 2 plus 6 times 6. So we're just using the same numbers for both spots. And we'll get 4 plus 36, or B dot B equals 40. Okay, so that's a basic process for how you do the dot product. And now we're going to take a look at some properties. So when you get to linear algebra, if you ever get to linear algebra, like if it's part of the courses that you need to take, you're going to spend a lot of time studying dot products, okay? So I wanted to really just introduce these properties before we move on to some different applications, okay? So one thing that you'll notice here is that we found that A dot B equals B dot A, and that is one of the properties right here. You can switch the order and it's fine. Now, a few other properties, some of which might make sense to us, like if you have 0 dot A, you're going to get 0, okay? If you have a constant, so in this case, M equals a constant, you can distribute that. The order doesn't really matter as long as you do A times B times, or A dot B times M in some order, you'll get the same answer. This one right here, number 3, is a clear case of distribution. So I can distribute, but I distribute with that dot. So A dot B plus A dot C. And then this one right here, number 1, we kind of saw in this last part of example 2b, where we were finding B dot B. And we're going to take a look at how we could find out that magnitude and see if it's the same as the magnitude squared. So from the last section, we learned about magnitude. So let's take this, let's find our magnitude right here. So the magnitude, or it's got double bars for B, equals the square root of B1 squared plus B2 squared. Squared equals 4 plus 36, which equals the square root of 40. Now that's nice, because if I square that, look at what I'm going to get. Square root of 40 squared equals 40. And so what we've just shown is that B dot B is equivalent to the magnitude of B squared. So again, when you get to linear algebra, you spend a lot more time proving that these things are true, and right now we just kind of want to do more of a basic introduction, okay? So let's move on. So we've got some theorems and definitions using the dot product, and there's 3 of these here that I want us to take a look at. So, theorem on dot product. If you want to find an angle in between 2 vectors, then we can define that as saying A dot B is going to be the length of vector A, and we're going to multiply that by the length of vector B. So remember, magnitude is the same as length times cosine of the angle in between them. That's what we're finding when we find A dot B. Now, what's more useful most times is we actually want to find out how big that angle is. So what is the angle between the 2 vectors? So that's going to be one of the first applications we look at. And all we do is we go ahead and divide both sides. So we take this formula, we divide both sides by the magnitudes, and we get this. Cosine theta equals A dot B divided by the magnitude of A plus times the magnitude of B. And remember, to find the magnitude of any vector, you're going to find the square root of the first component squared plus the second component squared. Okay, our last definition here, we're going to look at what it means to be parallel and what it means to be orthogonal. Okay, so when two vectors are parallel, it means that the angle between them is either 0 or pi. And that's because I could have an angle like a vector like this and a vector like this, and the angle in between those would be 0. Or, because directions matter, you could have one pointing this way and another one pointing this way. And that one would be in opposite directions, which is when you get theta equals pi. Now, perhaps the more useful one here is that sometimes you're going to come across a case where A and B are orthogonal. And orthogonal means that the angle between them is pi over 2, or you can say that the two vectors are perpendicular. Okay, so orthogonal means the same as perpendicular. So a picture of that might be something where one vector is going like this, and I have another vector going like this, and they meet at 90 degrees. Okay, so let's take a look at some applications of the dot product. So like I mentioned earlier, one of the common applications is to find the angle in between two vectors. And so we're going to go ahead and find the angle between vector A, which is 9i, and vector B, which is 5i minus 4j. So let's write out our formula. Cosine theta equals A dot B over the magnitude of A times the magnitude of B. So that's going to give us 9 times 5 plus 0 times negative 4. And it's a 0 because there's no j component for the A vector, okay? And then we're going to divide that by the square root of 9 squared plus 0 squared. That's going to give the magnitude of vector A times the square root of 5 squared plus negative 4 squared. And that will give the length of vector B. And so when we compute this, we'll get 45 in the numerator, and we'll get 9 root 41 on the denominator, which we can reduce to 5 over root 41. Now, because I don't want to find cosine theta, I actually want to find theta, I'm going to leave 5 over root 41 as an exact number. Because my last step here is to say, well, if I want to find theta, I have to do the arc cosine of theta. And so when I type that into my calculator, I get 38.7 degrees. And so that represents the angle in between these two vectors. But before we leave this problem, let's go ahead and put a visual with this so we can kind of see what it is that we're looking at, okay? Okay. So let's do vector A in blue. So 9i means that I've got something like this, and that is vector A. And B is going to be from here, I go over 5 and down 4, so that's going to be vector B. And the angle that we found, 38.7, is this angle right here, 38.7 degrees. All right, so we're going to stop here for video 1. Come on back for video 2, and we'll continue on applications of the dot product.